Hello, fellow gamers, or soon-to-be ones.
So I had this idea while playing Star Trek Online during the seasonal event. This is the Ryzian Lohula Festival, whatever, where you have a bunch of events that are occurring on a rotating schedule. In this case, it's what's called Horgan Collector event that happens every hour and a half. And during this event, your objective is to collect a bunch of items around the island that are scattered all over. You have approximately like 16 or 17 locations that you need to visit, from which you need to have 10 artifacts. And the first idea, or one of the first thoughts that came to my mind, was how to make this easier to figure out how to do this quickest and most painless. And since this is basically a traveling salesman problem where you need to visit certain number of locations with the shortest amount of distance that you travel, the idea was to utilize ChatGPT to write me a piece of code that will actually do this solving in some reasonable way. And to my surprise, it went smoother than expected, and I'll show you how it was done. So first and foremost, I checked ChatGPT. I'll show you how the conversation started. Let's put it full screen. So it's basically, can you show me Python code for solving travel and salesman problem where it needs to visit only n of m nodes instead of all of them? And it generated some code, and it was just showing some arbitrary properties of the algorithm. It didn't use any node coordinates. It was basically just numbers. So I asked it, can you add some simple node class there with XY coordinates? And it did. So I tested it locally, and when I fed it, instead of just this list of nodes, when I fed it the coordinates from the actual game, I'll show you later how I did that, it was taking a long time, and I wasn't sure if it's working or not, so I asked it why it's taking so long, and it explained to me how the permutations there work. So I asked it to add some progress bar to show me how long I have to wait, and while testing that, it was actually showing that for this specific combination of visiting 10 nodes out of the 16, it would take a long time, like even 8 on my quite beefy computer was taking, or estimating to visit 8 locations out of 16, it was estimating to last for 40 minutes, which was quite massive. And so I asked it if there is, because it mentioned during the question about the complexity, there is more efficient algorithms but that are just approximating it, but approximation is quite fine for me. I don't need to be precise. And it suggested a couple of algorithms. So I told him if it can pick one of the fastest algorithms and show me how that would be implemented. So it chose the nearest neighbor algorithm and implemented that. And I asked it so that the algorithm could be changed so that the route doesn't need to be a closed loop, because I don't need to go back. I basically can teleport in the game back to the starting location, so that's not an objective for me, and it actually affects the shortest route calculated. So it adjusted that as well, and then I asked it, because it was generated, it forgot that I wanted just the subset of the nodes, because I need to visit 10 out of 16, I don't need to visit all 16. So it adjusted the algorithm to do the subset again. And then there was an exception because the unvisited remove, one of the functions, was running into some edge case where this was already removed. So it told me how to remove that as well, because I was too lazy to debug it. And the result is approximately this piece of Python code, which I'll send to you. I'll put it in the description if you want to play around with it. It's just for fun. And when you run the code, see it in here, it shows shortest path and the coordinates and the number that I assigned to each number. the number that I assign to each of the nodes. And this is the shortest distance that I need to travel. So next time when I do the event, I just visit 1, 3, 4, 6, 7, 8. So it skipped 2 because I realized later that the 2 that I was noting was actually not valid location, so I needed to skip it. So we skipped 5, 7, 8, 9, 10, skipped 11, went to 13, then back to 12. So we'll need to visualize that for myself. So how I did this, I basically just took a screenshot from within the game, then fed it to GIMP, where I painted, I cropped it to just contain the locations. Like I wasn't interested, well, I'll show it later. Basically, over the screenshot, I painted in another layer the coordinates and number them 1 through 16. And then cropped it so that it contains only those coordinates, because I don't need to have empty space around it. And then the coordinates on the screen I just entered into the code, because it doesn't matter what the coordinate system is as long as is it octagonal or something, like it's linear in both directions. So it can start from 0, 0 here or 0, 0 here actually. So it doesn't matter really. So these are the latest destinations, and this is what was computed. So now I will use this nifty utility called transparent paint to record the locations. This one. Record the locations on my screen and then overlay it in the game. Hopefully it will work. So I need to visit, what was the sequence? Let's put it to a side. Pin it to the screen. So now I need number 1. Actually I can draw the path, so it's from 1 to 3 to 4 to 6 to 7 to 8 to 9 to 10, 13 and 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 location, optimal path. So basically next time the event will happen, I should be able to just follow this optimal route and be done with it fastest. Okay, that's all for what I had to show to you today. Hopefully you have some fun with ChatGPT and Python while playing as well as I do. And have a good one. Thank you for your time and attention if you made it this far. And in case you're interested in seeing more, please like, share, or even subscribe to this channel.